I'm honored to introduce our session speaker here, Sandy Bird, CTO and co-founder at Sonrai Security. Sandy helps enterprises secure their data in the cloud. Sandy was the co-founder and the CTO of Q1 Labs, which was acquired by IBM. And at IBM, Sandy became the CTO for the global security business. Sandy, all yours.
Thank you. Everyone, welcome to the conference, and good morning or good afternoon from wherever you're joining us from today. Again, as we talked about earlier, I spent my life in security analytics and have recently focused everything on cloud security. As we actually talk about cloud today and, how attacks happen in cloud and how you address some of these, we like to always talk about the context of what's different in cloud. And so today you're going to see a few kind of explanations of, some of the things that are different about how cloud is constructed compared to, say, a data center. In some ways, they're very similar. In other ways, they're very different. We'll talk through, the problems that some of these changes, which have given us great power in configuration and isolation, which are, in the end, probably something you can create a more secure environment with than what you're doing in your data center today. But of course, we need to understand them very well and how to protect those. And so we'll wrap up with several scenarios on how you can actually address some of these problems and fix them, regardless if you're using, platforms and products like Sonrai Security, or you're, even using some cloud provider tools or some open source. There's some great things you can do to actually help your problems today. Of course, the problem with cloud is when we started this, there weren't too many breaches, and now there are many, and you see this day after day in the press. What's interesting is that Kelly on our team tracks all of these breaches that have to do with public cloud, so AWS, Azure, GCP. And we actually started in 2000 doing this. It's a great map. You can actually go to, there's a URL here at the bottom, sonraisecurity.com/breachwatch, which has all of these breaches and the details and the links to them if you're interested in how any of these work. But what's interesting about them when you look across this, of course, is that there's multiple different reasons why many of them happen. Some of them are really simple misconfigurations. You have the public S3 problem, or similar examples in Azure and GCP as well, in terms of publicly exposed data with no authentication at all, misconfiguration. But often the attacks are more complex, and sometimes they have to do with highly privileged identities that get breached. Sometimes not the first identity that gets breached. Of course, the attack chain is still in play here. You still have lateral movement. You have all of those things. And some of the cloud controls have given us great ways to stop some of the common lateral movement. In enterprises, we had these very wide networks that once you were in, it was easy to move within the entire enterprise. Cloud has given us this great network segmentation and separation, between accounts and subscriptions, and you can configure networks ad hoc. And what's great about that is we actually solve some interesting lateral movement problems. However, we opened up other ones in terms of, it's very easy now to use an identity from one account, possibly using a trust relationship into another account, which allows you to jump through without having to have a network connection between those. And of course, we need to look at those, and we've seen those in several scenarios in these attacks. Of course, you always have the problem of the insider. If you read through these breaches, there's 100 of them now. You're not going to be able to read through them all. But when you actually, when you look through them, there's some of them that are, of course, the disgruntled employee scenario with too much power, and ended up terminating the customer's cloud accounts and things like that. So again, a very serious topic to talk about. We talked there a lot about, permissions and things, unauthenticated data stores. Well, of course, you're going to get breached if that's sitting out on the internet. But once you've got that configuration under control, which good companies do today, of course, the next thing that becomes the easy thing is can you get a credential, right? Can you steal a credential somewhere? Can you buy a credential on the internet, whatever it is? And inside of the cloud, of course, it's not just people identities. People use their credentials, of course, to access resources. We know that, you may log in with single sign-on, or you may have a local identity that you use. But all of the other things in your cloud, the non-people that are there, the systems, the services, the programs, the bots, all of those things, they have identities too. And those identities actually instrument your cloud. They're the things that lay the infrastructure out as infrastructure as code. They're identities that run the processes. They're the things that connect to the data. In the old world, we would have called them service accounts. But in this new world, they're often, depending on what they are, sometimes they're roles at Amazon, sometimes they're MSIs in Azure, service accounts in GCP. They have different names. And often underneath of those identities, there is still a credential. Sometimes it's a key. Sometimes it's a token, sometimes whatever it happens to be, a certificate, but they're still identities and they still have rights in your cloud. You always like to say serverless functions have rights too, in your cloud, and you need to know what those are, and you need to govern them the same way that you govern all of the other identities in your cloud, because they're just as much risk as the human identities to some extent. So, of course, when we actually start to look at these kind of non-people identities, it's good to start to categorize them and talk about each different type of them, so that you can understand, what we're talking about here. You obviously have in your cloud, as you build workloads out, the scenarios where you need to have a number of pieces of compute, we'll call them. Sometimes those are virtual machines, often brought in a model from your enterprise, moving them to cloud. Sometimes you have kind of net new things you're doing. Maybe you're using serverless functions for this first time in your workloads. And so those have identities. You also have scenarios where, the actual cloud services are doing things on your behalf for you. Maybe they're the things that are rolling out your infrastructure as code. Maybe those services are auto scaling your workload. And as we start to talk further in this presentation about ways attackers use those, they're all important. You need to understand them all and the keys behind them. You also have your IT administration accounts. You're probably collecting lots of metrics out of your cloud. So sometimes those are third-party services that have access into your cloud with, some form of a service account or enterprise application. They're always called different things. But all of those will have rights in your cloud too. There are also non-people identities that need to be governed, especially when they're from outside of your account. We've seen lots of issues around, third-party risk talked about, and certainly some of the most recent breaches, whether it be, a SolarWinds attack or something. Often it's from some third party that's introducing something into your environment. Sometimes it's a credential, sometimes it's a service, sometimes it's a piece of software, and that's being used as the gateway into your cloud. And so, of course, all those shared accounts and shared services and third-party services need to be accounted for, and they need to be governed the same way that the human identities are. I think in the early days of cloud, people didn't necessarily understand the amount of entitlements and rights that some of those were given. We talked a lot about software-defined infrastructure. Clearly, you need to roll all of this stuff out with code in automation, continuous pipelines that are updating this all of the time. They all have rights to do highly privileged things, create new data stores, read data from the data stores, provision identities in your cloud, which have alternative rights. So you'll often see a lot of scenarios where those are highly privileged accounts, and the keys to those or the rights to those need to be governed, very strictly in every environment. And of course, as you build your workload, you'll build, bots and analytics and all of these things, and they of course have rights too. So again, we're talking about all of that today. It's not that we don't talk about the humans anymore. The humans are a big part of this, but this is the kind of the change when we start to do the governance of this, because it is a complexity that gets added to the model. I always like to talk a bit about how identity works in cloud, because it's different. If you're coming from a data center and you're kind of used to, I always call it, forward identity, where, you intentionally set an entitlement on a database so that, it uses Active Directory as the single sign-in source. Sometimes things don't work exactly that way in cloud. And so it's always interesting to draw a little picture or a graph of how this works. You have the classic rights. You have a bunch of resources deployed in your cloud, whether they're VMs or data stores or net new platform as a service data stores like S3 buckets or DynamoDB tables, things like that. And of course, you have some identity that has access to those, often maybe an IT administrator or a DevOps admin or whatever it is. You have these new concepts that are in cloud sometimes, like AWS roles, which can be used for many purposes, but they have access to these resources. In Azure, you're going to have service principals. You may also take a key as an example, and the key may get rights to these, depending on the cloud vendor, how those keys are done. In Azure, they're done in service principals, and AWS, they're done right on user accounts. There's lots of different ways that these access keys can be granted. It's often the actual services inside of the cloud themselves will have the ability to generate an access key, which hopefully you store securely somewhere, like in a vault. And so you may have, rather the cloud secret stores. So you may be using, secret store or a key manager or something like that. You may be using third-party ones as well. We have a lot of customers that will use HashiCorp Vault to store their secrets in. There's some great plugins for that integrate natively with the cloud so that you can understand rights and entitlements through that key store, all the way from the identities that have access to it through to where they're actually getting the access to the resources. You have those key stores or even these individual cloud roles and service principals. Many other parts of the cloud have access to use those. And so you get into a bit of a reciprocal cycle here where, hey, you have a VM which has access to a secret, with access to another VM which has access to a secret. And you can create these long chains of identities fairly quickly in terms of who and what has access to what data. You also have concepts of things like single sign-on where, depending on group membership, you get access to things. And then those, cloud services themselves have access to, spin up new compute with identities on it and things of that nature. And you often end up with a scenario where you have a human identity that has access to a non-human identity, like a serverless function, a container, or VM. And that serverless function or VM has access to that key, which then has access to the service. And so when you start to look at entitlements, because you have access to, say, one VM, it may be giving you access to huge parts of your cloud. And that may not be the intended consequence of how you set the identity model up when you build it. Of course, the cloud providers know this. They built phenomenal tooling on top of the cloud in terms of policies and management to restrict access to these things, because that maybe the particular data store at the end of this path is the highly sensitive data store with your most important crown jewels data in it. Look, you can put boundary conditions and global policies and SCPs that would, as an example, stop anyone ever, deleting all of that data, as an example. You can put resource-based policies on it that control access to it, that override the IAM entitlements that maybe you're getting in the cloud. You can also do great things in terms of those individual data stores where the encryption keys themselves can have different policies on them. And if they don't align, if you can't, maybe you have access to the data, but you don't have access to the key, you still can't read it. And so there becomes multiple different levers for controlling rights and identity in the cloud as we do this. But it's not a simple puzzle. It's a complex puzzle. And in order to do this, you really have to model it out to understand the long identity chains that can occur. So when a new attacker is roaming around your cloud, and hopefully it's just your own red team doing it, and they're trying to understand how they were going to do the classic things that they do, in a normal attack, everything from the reconnaissance phase through to, lateral movement, all of those. There are some interesting things they do around identity that, the concepts of are not dissimilar from enterprise, but the way they get executed sometimes is. And so we like to talk about them in 5 types. There's 5 interesting ways that privilege escalation happens in these cloud providers. And again, some of them are somewhat unique in that they're kind of fun to talk about because there's something you may not have thought about before. The first one's really simple: direct self-escalation. Rather yourself, the identity you're working with, or the identity of the non-human identity, which becomes compromised, that piece of compute has the ability to modify its own privileges. So as an example, if you are the DevOps administrator and you can change the policies, and you have a policy on your role that says you can read S3 data, but you can modify that policy, well, then you could add to it that you could read DynamoDB table too, or you could add a policy to it that says you can actually create other users. And so you can directly escalate your own privilege. Again, big no-no. Every separation of duties example in the world will tell you that that's just never allowed. So you want to check that and make sure that none of your identities have that ability. Every build rule you have running around with Star has this problem. Of course, maybe those are risk exceptions you're going to accept based on how those work and how you've locked them down, but everyone can basically do this. The next one is kind of an indirect escalation. And this one gets a little more crafty in that you're not modifying the identity you have, but maybe you have a special policy that allows you to modify some other identity's credentials. And so as an example, if you had the ability to cut an access key on that credential and see it, you could then impersonate that other identity. And there's many examples of this kind of indirect escalation where, because you have some access to that other identity and you can manipulate it, you then can use that on your behalf. This is a scenario where being able to edit trust relationships as an example, you can kind of give yourself access to that trust in that other identity. And so it's something you have to also watch very closely. If a role has the ability to modify those trust relationships, well, then they can probably actually assume those trust relationships too, if they have the permission to even use one of them. So again, indirect escalation is always an interesting one to talk about. Unintended inheritance is one that was maybe even surprising to me 4 or 5 years ago when I started looking into this. I worked in the world where we always intentionally configured authentication mechanisms or access mechanisms. So if you had a SQL database and you wanted that SQL database to be backed by some form of single sign-on, you would have intentionally configured the SQL database to use Active Directory or an LDAP server or something for authentication. But in cloud, often the resources, when you're deploying these platform as a services, they just inherit all of the permissions from the cloud. And so all of a sudden that SQL server that you deploy will inherit, and it's sitting, let's use Azure as the example, it's sitting in a resource group, which is in a subscription, and the subscription's in a management group, and that management group is part of a tenant. Well, maybe there's a certain set of employees, or maybe there's a certain set of monitoring functions that have read access at the top level of that management tree. Well, they immediately get access to read the data out of that maybe very sensitive data that you just deployed. And so you didn't intend for that to happen. It's not like somebody ever configured the database and said, we assume all of the monitoring engineers and all the monitoring applications are going to have the ability to read the data out of it. But yet sometimes that happens in an unintended way. So you really have to understand how inheritance works in the cloud. And it's different in all 3 public cloud vendors and probably in several other ones as well. If you go into Oracle and these ones, it's different in every cloud how those rules are actually applied. And you have to know specifically based on your cloud how that inheritance is going to work. Confused deputies, where it gets fun. So those ones are ones that you may, say, okay, well, we all understand that. Of course, that happens, and we have checks and balances in place for that. But confused deputy is actually where now you get to manipulate a resource or service with a higher level permission than you have. And, this has happened in several attacks where, through a vulnerability or something, you get control of, maybe it's a VM, maybe it's a container, maybe it's a serverless function, whatever it is. But through some path, you've exposed some vulnerability. Sometimes it's not a vulnerability like we think of in software. It's a configuration vulnerability or it's an architecture vulnerability. Either way, there's a way that you can get control of this resource. And that resource has a higher level permission than you. And so from that, you can now manipulate that resource to do things on your behalf. We always tell people to be very careful with things like SageMaker, because again, with SageMaker, you can create pre-signed URLs, which give access to other locations. You can actually assign them roles where then those notebooks that get created can all of a sudden do things in your cloud. All very intentional, all part of the powerful model that the cloud vendors have built, but to be used in the right ways with caution. And so confused deputy attacks are ones that you have to be very careful of. I also see scenarios where sometimes you actually are able to steal the credential from the resource and then use that somewhere else as well. You see that, if you read attacks where a token was taken or a credential was taken out and then used from somebody else to explore the cloud accounts, that's often a similar type of pattern. And then the last one is resource permission escalations. And this one is, I always think of it as somewhat new in cloud. I always, use the example of this. In cloud, most of the resources you can apply policy to. And those policies sometimes give rights or takes rights away. Sometimes they cause the resource to do things on periodic basis. Sometimes they cause them to do things based on an action, an event happening, or a trigger. And so if you have the ability to manipulate those policies and rules, or you have the ability to manipulate those triggers and actions, you can sometimes get the resource to do things on your behalf that you don't have permission to do. And so if you go back to that example we said where we had the monitoring role, so you have a monitoring role that gains access to a data store and can read all of the data out of it, but the attacker wants to ransomware you, but they don't have the ability to modify the data. They can't delete it. They managed to get to a monitoring role, and luckily enough, it had read-only access, which is highly overprivileged to begin with, but they've got read-only access. They can't do it. However, they discover that they can modify the resource policy on the life cycle of the data. And so what they can now do is read all of your data. So they have a copy of it. They change the life cycle of the data to say, hey, by the way, instead of archiving this data once a day, delete the data once a day. And at midnight rolls around, or whatever the cycle is, or whatever the trigger is that causes that to happen, the data disappears. They now have the only copy. And so they never had permission to delete the data, but they had enough ability to change a lifecycle policy or a trigger or something that caused that to happen. And again, something you have to look at very carefully in cloud. So again, those are the types of scenarios that we talk about a lot in terms of, cloud attacks. Now, how do you solve these? There's lots of great ways to do it. And as I said, we'll talk about some of the solutions here. Some of them are very simple, and then some of them are much more complex, of course, as we go through here. But certainly, it's something you want to get control of in your cloud. If you're still struggling with configuration problems and public buckets, go solve that first. It's definitely a higher risk. But when you get into the point that your configuration is good, you've got it locked down, you actually are solving those issues. Now you really need to start looking at your identity in depth. And so the first thing we always tell people is, there's two types of identities that you got to be very careful of. One is, especially in cloud where people were early doing a lot of experimentation, they had a tendency to leave identities behind that were permissioned. And those dormant identities just kind of stayed in the cloud forever. They weren't provisioned with classic governance cycles. So there was no mover lever pattern that said, oh, well, we're not using that anymore, so take it away. So you need to go in and start looking at what's not in use. It's a really simple thing to do. Even most of the cloud providers have tools for at least if it's not used at all scenario, we can tell you that. And so if it's not in use, get rid of it. Shouldn't be there anymore. So on that side of the scenario, you can clean up a lot of risk just by removing the stuff that's not there. But there's a subset of accounts that are not used, which do have to remain. And so this is where you start to need to bring some amount of governance into this. And we always say, carefully manage your break glass accounts. Break glass is a term. Sometimes they're called fire call accounts. These are the accounts that you use to get into the cloud when all goes wrong, right? And so they're not used every day. They're never used. Usually it requires, a human to go into a vault and get out a key and all kinds of things to even use these scenarios in many highly regulated organizations. But you need to manage them. You need to know they're there. And you need to basically understand when they are used. And when they're used, somebody else in the chain of that application, whoever writes it, needs to know that that's in use, because clearly they're the ones that have the context that say, yeah, there was an emergency, we had to use it, versus no, somebody has stolen that credential somehow. And hopefully they're locked away in a way that never happens. But they have to be managed. If you don't know that they're there, they can have huge risk. And sometimes this kind of unintended inheritance happens through them. We've seen many scenarios with our customers where by some form of a monitoring group having access to the AWS organization account, their privileges are enough in the organization account that they can actually assume the right to the organization access role and then assume into a whole bunch of other roles. Again, intended consequence of the identity model, not an intended consequence of how you expected it to work when you configured it that way. So that's something to watch pretty carefully. And, you can absolutely kind of block those down pretty quickly and make sure that the ones that you have are right. The next one is, you do still need to certify these identities. If you're just letting your, development teams run around wild and let them use the excuse that I don't know what I'm going to do tomorrow, so everything can have star permissions, you run into a lot of problems because you end up unintentionally creating a lot of cross-account trust and stuff when that happens. And so you need to certify those identities. You need to understand the risk in those identities. And if you can do that, you can make sure that at least on some regular cycle, you can verify that it's still in use or not in use and get rid of it. If it's highly overprivileged, you can create a plan to, let's take some of these privileges away. And you can monitor the behavior of these applications. If the applications you're looking at are configured, with high levels of privilege, and all they ever do is monitor the resources, they certainly don't need to be able to create and delete them. It doesn't make any sense. And we'll often see where in certain environments, lots of monitoring functions are configured with really high levels of privilege, which make no sense at all. And when you look at what's used versus what's provisioned, they just don't map. And then this last column, of mapping out all of the entrust and the inheritance is key. Again, all of these clouds have these unique ways that you can jump between subscriptions and accounts and projects and all of these things. There's network paths between them using peering and all of these things. All of that, cross account project subscription trust needs to be mapped. You need to understand it. It's like your old network diagram, but sometimes it's identity related. It's not network anymore. And so you have to understand those maps, because those are what drive who and what can access the data in those accounts. And if you can avoid over privileging and kind of maintain the least privilege, at least for your really sensitive environments, you don't have to do it everywhere. No one's going to get the least privilege or zero trust across their whole cloud. It doesn't make any sense. But in those highly sensitive environments, it makes perfect sense to do it. So with that, we'll wrap today. I got a few more minutes here where I can ask a question or two. I will stop sharing in case there's something that comes up at the chat. But I'd like to thank everyone for joining. If you're interested in going in depth in any of these, or you're interested in Sonrai security, I'd encourage you to just go to the sonraisecurity.com website, and there's lots of options there. You can, talk to any of our experts. You can, basically go and request a demo if you wanted to see something like that. We also do risk assessments as well. So again, if you're interested in any of that, please just reach out at the website to our teams. They would love to chat with you about that. There is one question: what are some of the pros and cons as a centralized identity management on cloud? Again, remember, we're talking about the public clouds here. It's interesting, the differences between the clouds. Azure, almost every single customer that ever uses Azure is going to use Azure AD as their centralized, both human and in some ways non-human, using service principal identities in that cloud. They're probably going to sync it with their on-prem AD, and that's going to be the store for centralized identity. However, in Azure AD, of course, you can actually create MSIs for, virtual machines and things like that. And they're all part of that Active Directory model that's there that centralizes it all. But the entitlements are actually in the resources. So it's kind of a little bit, it's a centralized identity store, but all of the entitlements might be right down on an individual database. They can also be up in the chain as well. So, you're always going to see that centralized identity model. AWS is a bit broken that way. I shouldn't call it broken. It's a little bit different in that you may single sign on your users through whatever mechanism. You may use Azure AD to single sign on into AWS. It's a great way to do it. However, most of those non-people identities will not be in that store. They'll be in the AWS IAM model using, keys and trust relationships and roles and instance profiles and things. So it's a different way of doing it in AWS. And then in GCP, again, there's a lot of patterns there depending on how you're getting into GCP. So, what are the pros and cons of a centralized identity model? I think your humans had better come from some centralized service, right? Because your company already has a lever, mover, joiner process that puts those into the central store. Managing a individual's identity in AWS when you have multiple clouds or even an enterprise doesn't make any sense at all. You need to have that single repository. That said, that repository is probably not what's doing the entitlements for your cloud. And so you need something to control the entitlements for the cloud on that side. So anyway, hopefully that helps. Seems to be our one question. So with that, I will let everyone go, and thank you very much.